let's look at 3 more radical expressions and go through the process of simplifying those expressions. So here we have the square root of 48. Remember again, the process is I look at my list of perfect square numbers and I try to find a factor from the perfect squares for the radicand. And immediately I see that 4 is a factor of 48. 4 will divide into 48 12 times. And again, the way you test that is you simply pick up your calculator and start dividing to see which ones are factors. Remember, to be a factor, it would have to produce a whole number answer when we divide. But you don't want to stop there. In fact, I would suggest that you keep checking until you've checked all the way up through a number that's half the size of this number. That way you don't miss a larger one that might be a factor of the radicand, miss a larger perfect square number that's a factor. So in this instance, I would want to check up through 16. And in doing so, or really I could say up to 25, because half of 48 is 24, but that's not going to, if you divide it, you know if you divided 25 into 48, you couldn't get a whole number answer because it's more than half of it. And the smallest answer you could get and still have a whole number when you would divide would be 2, wouldn't it? So I would check 4. 4 works. 9 doesn't work. 9 into 48 doesn't give you a whole number result. But 16 into 48 does. If you take 48 and divide by 16, you get 3. So I can break apart the square root of 48 into the square root of 16 times the square root of 3. And the square root of 16 is replaced by 4, because 4 times 4 is 16. The square root of 16 is equal to 4, and the simplified version of the square root of 48 is 4 times the square root of 3. If we look at 72, well, if I'm going to check up through the half of that, half of 72 would be 36. Oh, well, that's one of my perfect square numbers. So I can immediately break apart the square root of 72 into the square root of 36 times the square root of 2. I would have found that 4 and 9 were also factors of 72, but I want to use the largest one in this case. So the square root of 72 can be broken down into 36 times 2. The square root of 36 is 6. So the simplified version of this radical expression is 6 times the square root of 2. When I look at 75, well, I can start to rule out some numbers. 75 isn't going to be divisible by 4 or 9 or 16, but it might be divisible by 5. They both end in 5. That sometimes is a clue that maybe they're factors. One is the factor of the other. And in this case, it is. The square root of 75 can be broken apart into the square root of 25 times the square root of 3. And the square root of 25 is 5. So the square root of 75 in simplified radical form is 5 times the square root of 3. Again, the process is to look at your radicand and find one of your perfect squares. If there's more than one, find the larger or largest, if there happens to be 3 or more. Find that perfect square number that's a factor, split the expression apart into 2 radical expressions, putting the perfect square number in one and the other factor in the other radical expression. Then that perfect square, you can take the square root of it and get the whole number answer, and you've simplified your radical expression.